I'm on page M1-193. I'm looking at practice number 1, but part C at this point. I'm computing and interpreting the correlation coefficient. So remember, this is just trying to talk about how strong of a linear relationship does this actually have? Should I use this equation to make my predictions? Do I have a very strong line? So I need to go to my my calculator for this. And again, just like if you watch the other video, I just have to show you my physical calculator for this device that I'm on. The thing is, a lot of people, when you did part B, this is all your calculator showed. Just a slope, just a y-intercept, which is good. It's nice to have that information, but it doesn't give me the r squared that we haven't used yet or the r. So we need to turn that on. So catalog, you should see right above 0. So I need to push the second button so I can access that. And it gives me every single thing that my calculator can do. I'm looking for diagnostic, which starts with the letter D. So I'm going to push x-1 right here because it's the alpha letter D. And then I'm just going to use my arrow keys to go down to diagnostic on, and I'm going to hit enter. I'm going to hit enter. So it's going to say, hey, I've done it, diagnostic's on. So if I go through and stat calc again, now it'll give me the correlation coefficient. I'm seeing 0.953 for R. So let me write that down for part C, 0.953. So I'm seeing a positive number, and I'm seeing a number that's pretty darn close to 1. It's not very close to 0. Like if I said, hey, you have 95 cents, you would say that's closer to $1 than that's closer to $0. So I'm going to say that compute and interpret, that my interpreting part of this would be that there is a positive, because R is positive, and I'm also going to note that it's strong, so I probably should have written it here. There is a strong, because it's really close to 1. It's not the closest we've seen in class, but it's pretty darn strong. So there's a strong positive linear association. I think there's a linear relationship between the year and the percent of people who aren't going and getting the dental care that they really need. So next, it also says, does it seem appropriate to use a line of best fit? Well, if I'm trying to say it seems pretty linear, I have a strong line shape showing up, then I'd want to say, yeah, because I'm close to 0, I want to be able to use a line. So I'm going to say yes. And it's because the correlation coefficient R is close. I think I said 0 earlier, close to 1. When you're close to 1 or you're close to -1, you have a very strong linear relationship. You can make a line out of this. Then they wanted the scatter plot for part D. Honestly, I'm not sure why they saved this for the end. Personally, I'd like to look at that first before I do any of this work. But you know, whatever, let's look at it now. So I'm going to go back to my calculator. I still have that data in here. I need to turn my stat plot on. So second y equals to get to the stat plot. Mine is currently turned off. So I need to hit enter so it's turned on. So the highlight, this black square flashes on the on. Then I would like my calculator to just look at the right spot. So I'm going to push my zoom button. And then I'm going to push the button 9, or I'm going to arrow down to it so I see zoom stat. And I do. I see this line shape. It does seem very much, I mean, there's a couple years that kind of flatten out, but the general trend, if you zoom out, the general trend is that I have a line shape. So I'm going to go note that here. It does say to sketch it. I'm not super picky on how perfect your sketches are, especially the way that we're going to be assessing you this year. I would just want to know that you actually did graph it. So I have the general trend on here. I should label that this is years and this is the percent. Plot the equation and the regression line on the same grid. Well, I forgot to do that. So this is, take the equation that we found in part B and make it put the line somewhere on here. There's more than one way to do this. The way that I find is easiest is just to push regular y equals, because I just want to type in a linear function. Oop, there's stuff there already. I'm going to clear that out. And I want to type in the equation that I already forgot that I should have written down. Give me a second. 0.512, 0.512, that's the number in front of x. Remember, use the x next to alpha. And then we subtracted that gigantic y-intercept, 0.584, I believe. So now I can zoom stat, and it adds the line in with me. Which is good, because if I would have done it, I probably would have tried to get closer to these ones, which would have been a line of fit, but it wouldn't have been the best fit. So I'm just going to sketch in, let's see if I can do this somewhat accurately. Yeah, something like that. Do you still think a linear regression is appropriate? That line does seem to model it really well. So the line fits the data. So yeah, it still is a really good model. We're going to get more tools to kind of assess whether a line is a good fit for your data. But for now, that's what we're going to use. We can use R to say how strong the linear relationship is. If you're close to 0, you're not strong, don't use a line. You can use the graph to say, hey, I see this line shape. The line fits the data. And so a linear regression is a good fit.